Here we have question 5 from 2019. Sets A, B, and C. A multiples of 2, you can see here. B multiples of 3. And C multiples of 4. Write down a number that is in A intersection B intersection C. So we have multiples of 2, 3, and 4. You could write them out if you want. 2, 4, 6, 8, 10, 12. 3, 6, 9, 12. You see where we're going with this? 4, 8, 12. 12 definitely. And then any other multiple of 12 will definitely go into them all. It's 2 by 3 by 4. You just multiply the 3 together. 6 4s are 24, which will be the next multiple of 12. They'd all go into 48 as well. So in the marking scheme, any multiple of 12 was given as what you could give here. So many different answers. And there was 10 marks for part A. Sorry, 5 for A and 10 for B. Third time lucky. 5 marks for A and B together. Explain why C is a subset of A. So it has to be a smaller version of A, or it could be in all the elements of C are in A. So C is the multiples of 4. A is the multiples of 2. Well, you have to explain all multiples of 4 are also multiples of 2. I think this is the best explanation. Therefore, C is a subset, looks like a C as well, of A. So we see maybe more of a C. C is a subset of A. You don't have to write this bit at the end, but therefore C is a subset of A. Part C, because C is a subset of A, there are 2 regions in the Venn diagram that have no elements. Write an X in each of these 2 regions. And then the second part of this one is each of the other 5 regions has some elements, and in each of these 5 write one of the elements in that region. So a lot of words here, but they're just looking for one element in each of the regions, and then 2 where there's none. So let's have a look. All of C is in A. Just going to draw a circle around A starting here. So here's A, and everything in C is also a multiple of 2, so it has to be in there, either here or here. It's a region. So where is there nothing? There's definitely nothing in here. That leaves nothing outside. And if we want to put things in the other regions that are just on their own, multiples of 2, the lowest one is 2. I think that's easy to start there. And a 3 there. They're definitely on their own and not a multiple of 4. And then from there, we could say that 6 is the next lowest number. I think I'm just working my way up here. 6. 5 is definitely not in there. So 6 goes in there. It's a multiple of 2 and 3. And then we left with one of all 3. What was the lowest of all 3? 12, wasn't it? The one we had. 2 by 3 by 4. Sorry, 2, yeah, 2, not 2 by 3 by 4. 12 was the first multiple, so that's definitely in all 3. And then what does that leave? Let's say we didn't go to the number 4 itself. That was the lowest multiple of 4. That's definitely in there. And then that just leaves one other region, and I've deliberately just left that second X out till the end. It can only go there now. And this question really is just starting with the smallest numbers, start putting them in and see where they go. And that's the end of this question 5. 15 marks for this one. So question 6, 20 minutes, quite a lot of parts to question 6. I would suggest for exam technique, leave till end. All these long questions, you'll have loads of time at the end. Leave this one to the end and come back to it. But for now, you're going to do it. So let's read from the start. Poppy and Ella ran a 5k race. Let's look at the graph. Total time along here and distance. So time and distance. Might bring in distance, speed, time into this question. We'll just jot that down. Distance, speed, time triangle. The simplified graph below shows the time it took Ella to run d kilometers during the race. One of the points on the graph A is marked. Here we have it here. It's in black. Distance is on the horizontal axis. We've already underlined it. For example, it took Ella 26 minutes to run the whole 5k. So that's a 26. And this is the distance 5. This was the distance 2. So the table below, which we have on the right here, shows the total time it took Poppy and Ella to run each of the given distances. Using the figures in the table, draw a graph on the diagram to show the time it took Poppy to run d kilometers during the race. And that's d between 0 and 5. So we have Poppy 5, 10, 17, 24, 30. Ella, we have 4, 2, 3 and 4 are blank. So we need to get the times here for 2, 3 and 4. That's bang on the line. So is the one before it, and looks like this one is too. So we have here, here, and here. So what numbers have we got here? 5, 6, 7, 8. The one before 15 and 20 itself. 8, 14 and 20. 8, 14 and 20. And we are, what do we have to use? If I draw a graph on the diagram for the time it took Poppy as well. And B was using Ella's graph, fill in the missing values as well. Okay, so we're kind of doing it the other way around. And then part C, show the Poppy's times. Do not make a quadratic sequence. So I'll just scribble this out now and we'll do Poppy's. Try and fit it in. So we have 1, 5. We'll do it in a different color. We'll do it in red. 1, 5. Then we have 2, 10. Quite linear so far. 3, 17. So much quicker. After 3, she's at 17. 15, 17. Then 4, 24. Again 7 kilometers, so she's gone 5, then she's gone 7, 7, and then 5, 30 up here. We were asked to draw the graph, so you would have a ruler. I don't have a band here. This doesn't really give me great straight lines on this, but it looks something like this. Your ruler will give it to you exactly. And show that Poppy's times do not make quadratic sequence. Well, second difference is quadratic sequence. 5, 10, 17, 24 and 30. Second difference has to be the same for quadratic. Let's have a look. 5, 7, 7 and 6. So we're going 2, 2, 2, 0, sorry, and minus 1. So you would say second difference not the same. Second difference not the same. Therefore, and you just repeat this, not make a quadratic sequence. So there was for parts 15 for A and B together and 5 for C, so there was 20 marks so far. And then D and E together are worth 10. And then F and G together are worth 10, so that would be 10, 10 and 20. 40 altogether. So let's have a look at D. It took Ella 26 minutes to run 5k. Work out her average speed. So that was the distance, speed, time triangle. I think it's always handy to write it down the way you were shown in class. We're looking for speed. So from the diagram, speed is equal to distance divided by time. Let's check. We're looking for our answer in kilometers per hour. Correct to 2 decimal places. So the distance is 5. The time is 26 minutes. So 5 divided by 26. Now to get that back to hours, minutes to hours, we multiply by 60. 5 by 26 over, sorry, 5 by 60 over 26. It's not working. I can't see how to work that out. Even I'm going to use a calculator. 11.54 kilometers an hour is what it's giving me here. And then tick the correct box to show what happened to Ella's speed. Now remember, you have loads of time in these questions. So particularly for the tick the box ones, take your time because they're always worth a good few marks. Tick one box only. Did her speed increase, decrease, or stay the same? So let's go back and have a look at, just double check, Ella's speed after 2 kilometers. So let's approximate. So in the first kilometer, it's 4. Then she's at, we had the graph, I'll just write them in here, 4, 5, 6, 7, 8. Then between 2 and 3, she's gone up to 14. So she's gone 6. Between 3 and 4, she's gone from 14 to 20. And then she's gone from 20 to 26 in minutes. We were asked what happened after the second kilometer. Well, has her speed increased? She's gone 4 kilometers in 1 minute, 4 kilometers in 1 minute, and then 6 kilometers. So her speed has definitely increased. No, it hasn't. She's gone 1 kilometer in 4 minutes, then 1 kilometer in 4 minutes. She started off really quick. The third one, it's taken her 6 minutes, the difference between 8 and 14. So is the fourth one, and so is the fifth one. So you can see the steepness of the line here, it stays the same all the way along here. So the slope will be the same. So let's tick that box that our speed has decreased. So don't start ticking loads of boxes until you're absolutely sure. Don't be doing like X and then an arrow to here and another tick and all this kind of stuff that you see in exam papers, and then it says no, correct, and you don't know what to correct. So please keep it nice and tidy and only put one tick on the exam paper. So in part F and G, which we worked 10 marks together, Kieran ran the race and he drew the graph below to show the time it took him to run d kilometers during the race. People get caught up on this, don't worry about that. The part of Kieran's graph marked C is a vertical line. So what has happened here, he was running, and this looks like a 5-minute period here, where the distance, he was still at the 2 kilometer mark. So don't be a smart arse and say he went to the toilet or something like that. It tells us he stopped for some reason. That's all you need to write for this part. G. Brendan says Kieran's graph does not show total time as a function of distance d, and it says give a reason why Brendan is correct. That Kieran's graph does not show total time as a function of distance d. So let's see here. If we look at this part of the function, an input can only have one output, but if we put 2 in, we get 7 different values here. We'll definitely get 10 and 15. So that's what you would write here. Input can only have one output. So function, and maybe add this, function can't be vertical. Might be a nice thing to add in here. And that's the end of question 6. Question 7, A was worth 5 for 2 parts, and B was worth 5, and part C was worth 10. Describe each of the following sets. Be as specific as possible. Natural numbers, n, positive, you could use the plus symbol. What are they? They're whole numbers, positive whole numbers. You might, in first year, have called them counting numbers. That would be fine too. Integers, z, so they're positive and negative whole numbers. If you want to shorten it down, you guys are all going to get this one correct if it gets asked. And then graph the following inequality on the number line. So -3. What's the difference between these two? We don't colour in the circle, and we do colour in the circle. So circle -3, nice big circle to show you're doing it. Circle 2, We include 2 because of the less than or equal to, so we colour this one in. We don't colour the other one in, we just colour in between the line if it's real numbers, which I should have said at the beginning. Real numbers, we're colouring in between the two because it includes all the decimals in between. Natural or Z, we just do dots. Then we're asked to use algebra to solve the following inequality. We can do it in a couple of steps here. I'm going to take away 8 from everything to get rid of the 8 in the middle, so that will be minus 7 minus 8 will be minus 15, less than minus 3g, less than or equal to 11 take away 8 will be 3. We can divide by minus 3, we'd have to change the sign of the inequality, or if you want to do that in one step, we could just change the signs and say plus 15, change this direction, 3g, and change the direction, minus 3. Dividing by 3, we get 5. We get 5. Dividing by 3, we get g, and we get minus 1. And we just use algebra to solve it. To this solve it, we could reverse it around if you wanted to write like this: minus 1 less than or equal to g, less than 5. For the solution to 7 part C, which was worth 10. First two parts were 10 as well. A nice 20 marks on the 2019 paper. Question 8 was one of these set questions that they love with the min-max part, minimum or maximum. This time it's work out the maximum number of people who could be in the U club. The Venn diagram shows the number of people in a U club U who play music and sport, where n is an element of natural numbers. So we're asked to work out the max here. We have 2n, we have 184 minus n, we have 52 and 125. Let's add them all up together and see what we get. Let's just see what happens. 52, 184 minus n. We have the 125. Pen's not working. 125. And we have our 2n. Just those 4 things. So we add these together. We're going to get, we will get, is it 309 plus 52, 361 plus n is what we're going to get in here. So if we look inside, we have 184 minus n in here. A bit of trial and error. If n is equal to 184, we'd have 0 in here, and we'd have 2 184s, 368 in here. Just a bit of trial and error. If n is equal to, let's say, 10, we're going to get 174 in the intersection. And we're going to get 20 over here, which you should see immediately is only 194, and we have 368 the previous time. So any number for n, it looks like, is going to, other than 0, is going to bring it way down. So the answer here is going to be n is equal to 184. I think to max it out. So that's going to be 361 plus 184 is equal to 545.